All right, so the title of this lecture is Making Your Code Classy. It's going to be an introduction into object-oriented programming, that's OOP, and using classes in Python. Just to let you know, classes are a general concept. They exist in JavaScript, they exist in C++. Most languages, I'm not going to say every language, but most languages have the idea of classes, especially if you're using object-oriented programming, you're going to be using classes. All right, but before we talk about classes, let's actually get into the motivation. Why do we want to use classes? What do they kind of offer to us? I'm going to do this with, we don't need this window. I'm going to bring up a new coding window. So okay, so let's get a nice new coding window here. And let's take a look at just a simple situation. I'm going to create a new file. If it will let me. Let's call it, I don't know, let's call it monday.py. I'm being lazy about naming. All right, so I want to create some logic, something to, that I might want to represent inside my code. So for this, I'm actually going to ask you guys for some information. So again, I can't see everyone on my Zoom screen, but do we have any dog owners out there? Anyone want to? Okay, Porphy, great. Can you give me some information about your dog? So can you give me your dog's name, maybe?
Winter.
Winter?
Yep.
All right, Winter, cute name. And then maybe can you give me your dog's breed?
She's a golden doodle.
Awesome. All right, so I'm just going to put golden doodle. All right, thanks you, Porphy. So that's Porphy's dog. Maybe we put dog owner's name. So we know it's Porphy's dog. Porphy. All right, cool. So we have some information that we're storing in our application. All right, so we have dog name, dog breed, dog owner. Great. So now we can, we have information. We use this however we may want to in our application. Let's call this pdog for Porphy's dog. And we're using Python, so snake case. All right, so this is information about Porphy's dog. Great, we've registered that. We have that in our application. Do we have one more dog owner out there that wants to share some information about their dog?
I will. I love my dog,
sure.
So I'll be happy to share. Her name is Ice.
Sorry, who's speaking? I can't see my Zoom.
Oh, sorry, this is Cat.
Oh, Cat. Hey, Cat. I see you now. All right, Cat's dog. So we have dog name. What's your dog's name?
Ice.
Can you spell that for me?
Like I-C-E, Ice.
Oh, Ice. Gotcha.
I didn't name her, but that was her name.
No, that's cool name.
Yeah, she's a boxer and border collie mix.
Say boxer collie.
Border collie, yeah.
Okay, I was gonna put boxer collie. I don't know my dog breed so well, but all right, and we'll put dog owner. Its owner will be cats, and this should be right here. All right, cool. So we have some variables tracking some information for us. So thank you for our dog owners for representing your dogs, but all right, great. So that's not B plus, that's equal. All right, so this is cool. Now we have some information in our application. Now, if we want to do anything with this, like simple print statement, I could print out something like, let's use string interpolation because we haven't done that recently. Let's do F format string. Let's say P dog owner. Dog. All right, so simple statement again. We're not doing anything too crazy here, but I'm going to print out dog owner's name or dog owner's name. Dog is named whatever the dog name is. So let's just run this again. Hopefully, you won't be too surprised by the output. I run Python Monday py. As I get Porphy's dog is named Winter. All right, great. So we are able to use this data however we want to, but there are some issues here. Well, issues are kind of in air quotes, as in this works, but why is it not ideal? Well, one thing that's not great about this is that these pieces of data are kind of separate. They're independent, meaning I have dog name, which isn't really associated with dog owner in any respect, aside from the fact that I named them in a similar manner, right? These are just individual pieces of data that aren't related or connected in any means. Now that's fine, but that's not great because let's say I wanted to, let's have a function. Let's create a function. Hopefully we know how to do that. So let's def keyword, we'll say show info. All right, we want a function where we pass in some information. Let's say name owner. And then we want to print out what we're printing out before. So let's say this function is going to take in a name, a dog name, and an owner name. And that's going to print out the owner's dog name is name. All right, to do this, well, we're going to have to, every time we call this function, call show info, we'll say pdog owner and pdog name. And we can also do this for cat's dog. So we'll do show info, kdog owner, kdog name. Again, this works, but the problem here is that these are individual data, right? Even though all these attributes apply to a single dog, right? Porphy's dog is named Winter, and Porphy's dog is a golden doodle. That's like a related concept. That's like data that both applies to Porphy's dog. Same thing with cat's dog. But we have individual data pieces here. So the issue, again, this is in air quotes, is that these items are treated separately, even though they should be connected and sort of should be one unit. This especially gets highlighted if, let's say, we want to return this data, right? Let's say I have a function and say def get Porphy's dog info. All right. And this is going to take in no parameters. And I want to return all this data, right? I want to return the name of Porphy's dog, the breed, and also Porphy's name, right? How do I return something out of a function when I have 3 different values? Again, these are all separate. I could, try to maybe return these separately. I think that's possibly valid. But again, I don't like the idea that these are separate, separate items, right? I'm just individually returning pieces of data. I want these to be connected because Porphy's dog is one object that has properties in it. It's not just a collection of properties, right? So here, what if I made a change? So instead of having individual variables, what if I use a dictionary? So I say pdog dictionary. Let's set that equal to, and then we could have some variables. Name is going to be Winter. Again, just translating this to a more kind of sensible data structure here. So I could have breed is going to be, well, let me just copy it. So let's type it. And we also have owner. And that's going to be Porphy. All right, so now I'd argue this is a better representation of Porphy's dog because Porphy's dog has all these attributes. So it's all kind of packaged up into one, kind of one data structure. And now, again, you guys might be thinking, what's the big deal? Well, I think, again, it's just easier to work with this data now that it's all kind of condensed here. So actually, let's do this for cat's dog also. Dog name is Ice. It's interesting, we have Winter and Ice. That was a total coincidence, but nice little theme we got going on here. All right, so now the reason I would argue this is slightly better is because instead of having individual pieces of data, we just pass in like an info dictionary. And here I could call info.owner, info.name. So the benefit of this is now let's say I add like 20 more attributes to this data. Like maybe I add favorite food, favorite toy, tricks that they know. I could add that to my dictionary here, but my input or my parameter here never needs to change. Right? I don't need to add 20 different parameters for 20 different attributes. It's all kind of packaged up in this nice dictionary. Do you guys kind of see the benefit there? Maybe, I don't know. Also for get info, I can just return pdog dictionary. It's all one package that I could just return together. Are you guys buying what I'm throwing down here? Are you guys kind of still like, what's the big deal here? Anything?
Yeah, we get it. I mean, at least I understand what you're trying to do here.
But yeah, again, using this dictionary to kind of have all the data packaged together rather than individual. And that, again, makes my life easier because now if I, as I said, add a new field, hey, Kat, what's your dog's favorite food, if you know?
I mean, what isn't her favorite food?
Everything.
She likes baby carrots.
Oh, that's interesting. Baby carrots. I love baby carrots too. All right, so now that I add a new value, again, my my parameter here does not have to change. My return value for Porphy's dog. Let's say, Porphy, what's your dog's favorite food?
Mainly garbage if she could get into it, but Sachichon, the thing that we feed her the most.
What was that?
Yeah, you can put garbage.
All
That's
right,
fair.
garbage, delicacy for dogs. All right, so again, now that I'm adding values here, I don't know how to change my parameter here. I don't know how to change my return value here. It's all bundled in the same thing. So that makes my life as a developer easier because all this data is kind of nested together. So, I could add here, and favorite food is info.food. Yelin, you have a question?
Yes, just want to clarify, make sure in the get Porphy's.info, the return statement, is it only return the entire dictionary or does it return something specific?
This return the entire dictionary.
Okay, thank you.
Yeah, I mean, you're right. I did change it from before because before I was, I think, just returning name and owner. But here I get everything returned, and I can access whatever I want. If I don't care about favorite food, whatever. As whoever's calling this function, like if I say, info equals get Porphy's dog info, I can do whatever with this return value. If I don't want to use it at all, that's my freedom as the caller of this function, right? So I have info. I have access to the name, breed, owner, and food of that dog, but again, I don't have to use it.
Okay, thank you.
Okay, so this is where we're going, but notice there's still some issues with our design here, right? When I added cats, dogs info, I had to kind of copy and paste and kind of redo this. If we had like another dog owner, do we have one more dog owner out there just to get more pets represented? Justice, let's hear about your dog.
So we can go with Mercutio.
Okay, there's no chance I spelled that correctly, so I'm going to go with Murray. Sorry, how do you spell Mercutio? We'll go over that.
Mercutio.
Yeah, there's no way I was going to spell that. Okay, cool. Mercutio, what breed?
Yep. Shakespeare. He's a Great Dane mix.
Great Dane, big dog. Let's give up Great Dane. Owner will be Justice, and then any notable favorite food?
Popcorn.
Yes, popcorn is amazing. All right, so again, I added Justice's dog's info, but notice I had to copy and paste it. Again, it wasn't too much effort, but that's only because I only have 4 fields. What if I had 20 fields? It's gonna get kind of tedious to recreate, this object over and over for each dog info that I wanted to represent. So what if, let's clean that up. What if I created a function that does this for me? What if I say create dog info? This will take in name, breed, owner. So we're gonna pass in individual data and then kind of pass back a package of data. So they return a dictionary that's going to have that data for us. All right, I promise I'm getting somewhere here. I know this isn't too interesting, but we're gonna see our motivation here. But effectively what we've done here is the beginnings of using a class. Doesn't seem like it, but now we've, instead of doing this, I could call my function. So create dog info. I wish I didn't delete that data. There's winter. I forgot the breed already. Golden doodle. So let's do this way. We got winter, golden doodle. I'm not going to do this for all of the owners, but hopefully you guys can understand. If I want to do it, it's simpler now. I just need to pass the data, and it's going to give me back the objects. So I kind of have like a factory or something that creates the data package for me. I can do that with Cat's dog and Justice's dog. But now this is, again, kind of reusing code. And that's the whole idea of creating functions. So we have reuse logic rather than copying the same logic over and over again. Anytime you catch yourself writing the same logic or similar logic over and over, that should raise like a yellow flag in your head saying, hey, maybe I could kind of condense this into a function or some reusable piece of code. Okay, so we created this function, and this is kind of the beginning of using a class where we kind of nest data together. We have like a method that creates the item for us. So we're on the ways of using classes ready, even if you don't realize it. So that's great. Now your question in your head might be, well, okay, Encore, well, why can't I just use dictionaries to represent data? Why do I need to learn about classes? Good question. Dictionaries can do most of the work for you that we're going to achieve with classes, but classes add additional benefits that dictionaries don't have. And we're going to see some of those with our introduction to classes. So here, just a rudimentary, data collection and display, nothing too exciting going on, but we just keep things simple. I guess I could do one more example just to see how it makes life easier. So I do this. Cat is the owner, baby carrots, delicious. All right, so again, it makes my code more condensed and I'm reusing this piece of code. All right, you guys see that? Thumbs up, maybe? All right. Let's talk about classes then. So we're going to talk about object-oriented programming and specifically classes, how we use them, why use them in Python. All right, so backing up a step, let's talk about the goals of a software developer. And this slide, you're probably going to see multiple times because this is my favorite slide, as simple as it is. There's two focuses for a software developer. One is to solve a problem, right? So we give you a problem like, hey, balance parentheses. We need to get the correct answer. So that is getting the correct results, solving a problem. But just because you solve a problem doesn't mean you're done. Your job is not done. You need to solve a problem well. So there's so many ways you can improve your code. I've kind of bucketed it into three major items here. Structurally, which means better code design. Functionally, which is better usability for your end user. And algorithmically, which is better efficiency. So let's kind of just get a high-level introduction to structurally. Many things you can do make your code better. Code organization, how you organize your code, how you create separate files, separate classes, use proper data structures. That's important for code organization. Excuse me. System architecture. This is more important for like larger scale applications. Like, all right, are you using a peer-to-peer network? Are you using a client server model? These are decisions that you need to make up front. That's going to dictate how your application kind of scales and grows from there. Future proofing. This is an interesting concept. So as you're developing applications, there's no way to guarantee what the future is going to hold, but there are some educated guesses you can make about the future. For example, if I create an application today that supports like 100 users, that's great. But the question is, what if my user base grows from 100 to like 1 million users? Can my application handle that? How would my application need to change to handle that new scale of users? If you coded your application to only work with 100 users, and then you have 1 million users like the next day, and you got to change your code entirely, that's not good future proofing. You should anticipate potential changes to your use cases, potential like features that might be added later. Again, if I need to add a new feature, do I need to burn down my code base and rewrite it from scratch? Or can I easily add some new features, new capabilities to my code? So this is important decisions, mindset you should have as you're coding. Code it for today, but also add in flexibility so it could change for the future. Again, there's no guarantees. It's possible to know the future. We could anticipate what might, what the future might bring. Other small things, these are things that you guys should be practicing and getting better with: reliability and readability. Reliability is the idea of, hey, if something goes wrong in your application, does it crash? Does it report the error to a user? Does it give, does it gracefully kind of, is it reliable? Does it, does it provide the user what it needs? Even if things go wrong, is that error reported, handled, error checking, stuff like that, reliability. Readability, these are simple concepts, as simple as commenting your code, right? When we create large scale applications that could be 100,000 lines of code, when someone else new comes to that, they shouldn't have to, struggle to read the entire application. Comments are really beneficial to yourself as developer and other developers. Excuse me. Also, other things for readability, using sensible naming of variables, using common code practices and code styling. All this matters. Even though it seems minor, for large scale applications, these things really matter. So make sure you're naming your variables appropriately. Don't use silly names like X or bananas if you're not representing bananas. Try to name your variables appropriately. Use proper syntax. So for Python, we use snake case. For JavaScript, we use camel case. Might seem minor, but again, when you're dealing with other people's code, you want to have a consistent look and feel to the code so that everyone can kind of easily adapt to your code as needed. All right, so those are just a few ways you can improve your code. Again, commenting, error checking, error handling, future proofing. Again, you guys kind of get the idea here. Now we're going to switch to programming paradigms. This is the idea of designing. So how you actually structure your code. So this goes back to code organization. Programming paradigms. Object-oriented programming is our key focus here. But I just want to mention it's not the only programming paradigm that is used in the world. It is a very popular one. I'm going to dare say probably the most popular one, but don't quote me on that. Especially like in modern day, like object programming is the focal point for a lot of organizations. Now, just to highlight, there are other programming paradigms. There's functional programming, procedural programming, structured programming, and logical programming. I'm not gonna pretend that like I know all of those. You guys can Google them. Like I'm familiar with functional programming. The other three, again, I mostly just read the Wikipedia page. Like, all right, I understand that they exist, kind of what they do, but I am not a professional or expert on what all these programming paradigms do. I am really familiar with object-oriented programming because that's what I used in my past job. Again, that is used extensively throughout the industry, so that's what we're going to focus on here. Okay, so the short form for object-oriented programming is OOP or OOP. You'll probably hear those throughout, so I'm going to be using OOP because I just want to say this long word or long words all the time. Any questions about, again, making sure we understand why we need to kind of, organize things better and programming paradigms? A lot of times, again, your company that you go to will already have an established paradigm, so you're not going to really like choose. There are some times where maybe you're creating an application from scratch. You might have to decide, all right, does functional programming make more sense or OOP? And that's some decisions that goes into like your system architecture and just figuring out what you need to do before you actually start creating it. Well, let's talk about the features of OOP. And again, this is a very boring slide. I'm going to say that up front. But the reason I want to show this slide is because this can be popular interview questions, especially if you're interviewing for an OOP job. These are the 4 pillars of object-oriented programming. They sound like kind of really fancy words, but they're really describing pretty simple concepts that are offered by OOP designs. The first one is inheritance. So inheritance is the idea where you share similar features and attributes. Again, this goes back to reusability of your code, right? Not repeating yourself, not being redundant about things you're doing. Inheritance this feature offers the ability to reuse logic and functions, or I guess design functions from classes again. So we're going to talk about inheritance, I believe, on Thursday of this week. So there's more to come. We're not going to talk about it today, but this is very useful, especially again, the more and more your projects grow, as your data grows, inheritance becomes much more useful. Polymorphism, again, definitely a fancy sounding word. It's, to be honest, a little difficult to identify in Python because Python kind of automatically does polymorphism for you. But the idea here is that objects can kind of take on different forms based on different use cases. So for example, if we had like a dog represented in our application, sometimes it can be treated like a dog. Other times it can be treated like an animal based on what our logic is doing. So if our animal just cares, hey, how many, is this an animal or a plant? Well, that, it can take in a dog object and treat it like an animal and know, hey, this is an animal. We don't care if it's a dog, cat, bird. We just care it's an animal and we'll do something based on that. Or if we actually care that's a dog versus a cat, that is automatically done through language where, again, one object can take multiple forms kind of automatically. Abstraction and encapsulation, these are kind of similar concepts, but abstraction is the idea where you hide complexity and only expose, you hide complexity and kind of put it into a box and hand it to someone else. So for example, if I were creating a dog class and that had like a lot of complicated logic behind the scenes, everything should be kind of, whoever's using my dog class shouldn't have to worry about how my dog class is creating the logic or doing whatever it's doing behind the scenes. Sorry, that was probably really confusing. Again, the idea here is you create something and you package it away, and whoever's using that something, whether it be a dog class or an animal class, doesn't need to know all the nuts and bolts of that class. All they need to know is like, hey, if I ask for the dog's name, I should be able to get the dog's name and that's all I care about. I don't care how the dog's name is returned. I don't care how the dog's name is stored. That complexity is hidden away from me because I don't care about it as a developer. Encapsulation, the idea here is that data access is restricted based on needs. Again, kind of a mouthful to say, but the idea here is you only expose what you want to expose from your classes. So let's say I was creating a human class or a person class, and I wanted to store the social security number in my class, but I don't want to expose that social security number to whoever's using my human class. Well, the idea there might be, I might need to use a social security number to validate that, you are a US citizen, for example, but I don't want to show that social security number to anyone that's using that data, right? Because that's usually private information. So you can design your classes to kind of hide information and only show what you want to show. Again, that gets a little tricky in Python, but again, these concepts are for any OOP language, not specific to Python. All right, so again, these are buzzwords. I know this is kind of boring information, but they're important to know. So if you're preparing for an interview for an OOP language, definitely make sure you understand these 4 pillars, be able to describe them, because I have seen in the past where they will ask you, okay, can you tell me what data encapsulation is within OOP design? And then again, regurgitating it, not the best interview question, I'll admit, but sometimes they just want to be very technical and describe OOP concepts. So make sure, you understand these concepts with OOP, and just doing a quick Google for them should suffice to get the understanding for what you need to know. All right, boring slide, let's proceed from here. Let's talk about classes. This is actually where you actually get to coding. So what are classes? Classes are user-defined data types. So, in Python, JavaScript, we have predefined data types like integers, Booleans, even lists and arrays. Those are data types that already exist. But if I want to create my own data type, I'm going to create a class to represent the data that I'm trying to represent in my application. Another thing that we kind of saw with our example before, classes are used to tightly bind data and also manipulation of that data together in one single package, right? We don't want just individual values that can be, kind of just floating out in space. We want them to be all nested together in one item. Because again, if you think about the idea of a dog, for example, a dog is a collection of properties and attributes and capabilities. It's not just a random assortment of, hey, dog name combined with dog breed that you kind of just like are independent of each other. A dog has all these properties together. Again, OOP is very useful for mapping real world objects. So we just saw dog. Again, a lot of times your application wants to represent data from the real world, whether it be like a user account where you want to have a name, address, stuff like that. Or you want to represent a dog, represent a storefront. Again, very useful for mapping real world things. That's why OOP is very predominant in industry. Andrew, you have a question?
Yeah, I have a question about classes. So you said it's a user-defined data type, as in, since we define it, could a class contain like a list, a dictionary, and another list?
Yes.
So it's just basically whatever we want it to be.
Yes, it's kind of like, so I view it as like Legos. So your Lego blocks that you have are like integers, strings, Booleans, lists, and all the other types that we talked about. Those are your Legos that you have right now. That's what's pre-built into each language. Classes are effectively, you're combining those Lego blocks into larger chunks. So at the end of the day, you're still dealing with integers and strings. It's not like you're making up a new like super int, for example, but you get to represent the data together and bundle it together. For example, like a dog might have a name and an age. So you combine a string and an integer together kind of in one package, because that's what you're trying to represent.
I just had one more question that
Go for
answered
it.
my first one. So object-oriented programming, even though it's called object-oriented, it's not really referring to like objects in the JavaScript sense.
Correct. Yes. I'm
Yeah,
glad you
it's-
mentioned that. So
okay.
yeah, there are objects in JavaScript, which I like to call dictionaries. Those are separate. Yeah. So we're not talking about dictionaries in that sense. Objects, it's just a more, I guess, just a word, the word object, not the programming data structure of objects. But yes, last bullet point, and then we'll take a short break. This is the most important thing that you should take away from this slide. So if you don't really care about the first 3, fine, store that away. But fundamentally, classes represent a concept or a blueprint. It's just an idea. And then you're going to create actual objects or instances in your code. Again, the terminology here is very important. So understand that you create classes, and a class is just a concept. right? You have an idea of a dog. So if I'm imagining a dog, well, I know dogs usually have like, 4 feet, they say woof. They usually like all kinds of food. That's my idea of a dog. But when I actually think of a specific dog, like Porfy's dog or Cat's dog or Justice's dog, that is an actual instance of a dog, where Porfy's dog's name is Winter. Porfy's dog apparently likes garbage. Cat's dog likes baby carrots. These are instances of dogs I'm referring to versus the idea of a dog. So the idea of a dog is I would create a dog class, a class definition to define what dogs might look like. But once I actually create an actual dog, that's an instance of my dog class. All right, so again, make sure you understand the difference between a class definition and actually creating an instance of a class. And we're going to see this, I promise, in code after the break. So it should make more sense, but just kind of solidify that in your head. We're creating concepts or blueprints with classes. And when we actually use those classes, that's when we actually create objects or instances of those classes. Okay, a lot to digest there. Promise we'll get to coding after break and actually see this in play, which will be much more useful. So let me pause recording here. All right, so we talked about classes. It's just the idea of creating user-defined data types. Again, the idea is we're creating a concept in our code, and we're going to create instances when we actually use classes. So let's go back to our coding window quickly. I'm going to create a new file and call it, classes.py. All right, so I'm going to use the same idea here where in Monday.py, we're creating some representation for dogs that some of our students have. We're going to do the same thing, but with classes now. So the very first thing is, how do we create a class? Now, if we go to our slides, this is the basic syntax. Use the class keyword. You name your class. And the important thing I want to point out here is for Python, we actually do use camel case for naming our classes. Now, it is kind of odd that we switch between camel case and snake case. Just know that's whatever the standard is. I didn't make the rules, but I do follow them. So again, class is the keyword, and then you want to name your class in colon, and then you add your items to your class. There are 2 main items you're going to be adding to your classes. Again, this is terminology. Attributes are basically data members, i.e. the variables that your class holds on to. And then methods. Methods are just another name for functions that interact. I have a typo there. Interact. No, I don't. Never mind. Interact with your data members. So again, you have data, and then you have functions that manage the data, whether updating the data, returning the data, doing whatever for the data. It's all internal to your class, and that's the important idea of designing this. Everything happens internally. Whoever's using your class should not worry about the implementation inside of it. All right, so let's actually create our class here. So I'm going to create a dog class. So I'm going to use the class keyword, and then dog, again, uppercase D, because we use camel case. Again, this is just naming conventions. It doesn't matter, like you don't have to name it uppercase. I could name it dog undercase, lowercase, but just following conventions, you want to have uppercase for your name, colon, and pass. All right, so this is a most basic class you can create, has no implementation. Let's say we want to create an instance of it. So again, this is our blueprint. And then we want to create an instance. To create an instance, we simply create a variable. So let's say we had Winter, that was Porfy's dog. We create a dog instance. All right, so notice the syntax here. Again, we have our class name, uppercase D, dog. To create an instance, we call the class with parentheses. This creates an instance that's stored in a variable. So again, this is just a variable, just like I could do value equals 1, data equals some list, whatever. This is just a variable I've created that's holding on to a dog instance. This variable is holding on to an integer instance. This data variable is holding on to a list instance. That's just a different data type that I'm using here. Here I have an integer, here I have a list, here I have a dog data type. What questions do you guys have about creating a class blueprint or creating an instance? Okay, so obviously our dog class really isn't that interesting, right? We have nothing going on here. We have a pass statement, which means this dog doesn't really represent anything. But we still are able to create a dog instance that has no data or methods associated with it. But let's actually make it more useful here. So I'm going to add what's called an initialize initialization method, also known as the init method. Now, important thing I want to point out here, you must name your method underscore underscore init underscore for this to work properly, because this is what Python expects in your classes. If you don't use an init method, things aren't going to work the way you want it to. For this init method, again, this is just a function. The reason I call it a method is because it's a function inside of a class. It's just terminology. So anytime I say method, just think, okay, function inside of a class. So I'm creating a function or a method here that takes in a parameter called self. And we're going to talk about this much more, so stay tuned. After the self parameter, I'm going to pass it some additional parameters. In this case, I'm going to pass it name. And then I'm going to write some weird line of code called self.name equals name. I know there's a lot of new stuff going on here. You're probably wondering, well, what is this self item? Why is VS Code highlighting it? What am I doing with it by doing .name? All questions should be answered, and if not, definitely ask if you're still confused. But this method, again, this is a special method. So let's comment this. Special method used to initialize a class instance. Right, so again, it must be named underscore underscore init. If you name it something else, Python's not going to know that to call it to initialize your class. All right, so now what I've said here is I want to initialize any dog instance I create must have a name. So I need to pass in a name to create a dog instance. So actually, let's comment this out and run this quickly. I need a pass statement. Just want to run it to make sure I don't have any syntax errors. So I'm going to do Python classes.py. All right, it ran. No, there's no output because I haven't printed anything out. But if I add this init method in here, right now I'm saying every dog that gets created must have a name. That is not optional right now. So if I do Python classes.py, notice I get an error. The error is saying you're missing argument of name. Because the way I've designed this, oops, this past image should not be here. The way I've designed this is saying every dog instance must specify a name. So if I want to specify a name, I pass it as a value in my dog, where I'm creating my dog instance. So here, let's say winter is our dog's name. Now we're passing a value, and that's automatically, or I can say automagically, being passed to our init method. Notice we are not actually calling our init method ourselves. We are still calling our dog class and passing it some value. This is kind of just the way our classes work. So the init method is automatically going to be called by Python. It's going to accept the parameters that you pass it. Now there's some things to notice here. Notice that I also have this self parameter, but I am not passing that here. This is not meant to be passed by myself. This is, again, automagically passed by Python to your method, and we'll talk about what that self actually is doing. But this is required. Self, you must have a variable that captures the instance, and we name it self kind of as a naming convention. This could be named anything I want. It could be named something. This would totally work. Just know that self is a naming convention. It is not like a reserved keyword for Python. So this, what I've coded here, will work exactly the same as before, because this is simply a variable name or a parameter name that I'm giving. But by convention, it should always be named self. It's so much of a convention that VS Code identifies it as a special, like, reserved keyword, even though it's not reserved really. Okay, so again, init method takes in self, always has taken self, even if you're not passing anything else. And then every extra parameter you want to add, you add on here. So now that I added a name, I can get that name off of this instance, right? Because winter is a dog instance of a dog class. And now I've actually stored a name inside of that dog class. So if I wanted to actually access it outside of the class, I could do something like print winter.name. So yeah, we are using the dot notation here. In fact, this self.name is literally the same thing as winter.name. Self refers to the instance that is calling a particular method. Now, again, it takes a while to digest, but just know self, Python will automatically pass whichever instance is calling this method. In this case, we are not calling it ourselves. but self is going to refer to actually the instance that we're creating. So here, if you want to imagine, this could effectively be winter and winter.name. Again, we don't want to call it winter because every dog is not going to be winter. Like we're going to have multiple instances of this dog. But effectively what we're doing is we're taking a value and we're kind of binding it to that instance here. So now name is a property of our dog that we created. Right, so we're taking a separate data value and then kind of attaching it to our instance that we created. So now name is always tied to our dog instance. But again, here we don't want to use winter because this can be used by any dog. So that's why we use self as like a generic name for whatever instance is being created. So we created more instances. Let's say Ice was Cat's dog's name. We could say dog Ice, and then we could print Ice's name here. So again, the self is saying, all right, you're creating a dog named Ice. I'm going to attach this name to this instance so that you can extract the name off of that instance if you want to. We have one more dog here. We got names already. We had Mercutio. I'm going to name the variable Murray. So again, your variables can be named whatever you want. They don't really matter, but here, Mercutio. Did I spell that correctly? All right, so we've created 3 dog instances. This is, again, the same ideas of what we're doing before, right? Before we created this function to create a dictionary for us, and we just call that function with whatever values wanted, like winter, golden doodle, porphy, and garbage. That's what this function returned. That's essentially what this, that's essentially what this init method is doing for us. We are passing it values, and it's giving us like an object back. But in this case, it's an instance of a class that's coming back to us. Let me pause here because definitely some new syntax here, probably some questions that arise. What questions you guys have about creating a class, creating an instance, or even this init method in self? That definitely probably has raised some questions. So please ask anything that you're confused about here. I see 2 hands raised. Unfortunately, I cannot see who you are, so feel free to ask.
I was wondering if you can re-explain what init is again.
Sure. Yeah. So init is a special method, right? So this is, it has to be named init, specifically underscore underscore init underscore underscore. This is a method. Python will automatically call this method when you try to create an instance of this class. Right, so when we try to create a dog instance right here, Python is automatically going to call this method and going to pass it any values that I chose to pass. In this case, I'm passing a name here. So I created a parameter called name so that I can actually accept that value and then basically attach it to that instance. So again, self refers to the instance here. Let's comment that. Self refers to the actual instance that we're using. So I'm creating an instance here, winter. That's what self is going to refer to. And this is something that Python is automatically doing. Notice, again, I am not passing winter here as a parameter, even though that's my instance. Python is automatically identifying what the instance is and going to attach, basically create a variable called name on that instance and assign it the value here. Just to make this a little more clear, I can call this dog name and dog name here. Again, this is just a variable. This is a parameter. I can call that whatever I want. That does not need to match what I'm creating here. So I'm creating a new variable called name on my dog instance, and I'm assigning it the value of dog name. This is totally fine. Again, just want to make sure it's super clear what I'm doing here. This is basically creating a variable, just like I create a variable called x equals 6. This is the same thing I'm doing. I could do self x equals 6. The only difference here is this x equals 6 kind of exists anywhere. This x exists particularly on this instance. So each dog instance I create is going to have an x variable as a part of it. So I could do, it doesn't make sense because x is a terrible name and doesn't have anything to do with dogs, but I could do winter.x because I've created a variable right here called x.
Can you initialize with a default variable or your parameters? Okay.
Yep. absolutely. So yeah, methods are basically functions. So all the things we do with functions apply. So let's say every dog, if we don't specify, is going to be named Fido. So in this case, let's say, here for the variable Murray, if I don't pass anything in, it's going to take in a default value of Fido. That'll be dog name here. So self.name, in this case, Murray.name will be defaulted to Fido. Yep, that is valid. I mean, in this case, wouldn't make sense because dogs don't have default names, but dogs can have maybe a default age will be 0. So when they're born, they're age 0. So you can do whatever data you want to store. That is what you create in your user-defined type. So we're creating a user-defined type of dog, and then we're storing whatever information we want to. Again, I'm just going to reiterate this. Hopefully it doesn't get too repetitive, but again, self. Understand that we do not pass this in, but we use it in our method here to access the instance internally. So now self.name refers to Winter or Ice or Murray, depending on whoever is calling this init method. And that init method is automatically being called when we create our dog instance. And this is a special method that we are creating so that Python will automatically call it for us and create this variable during initialization. A lot to take in there. Please ask if you have any questions. But again, aside from special methods, we can create our own methods. So I'm going to create some extra data. So let's say instead of just storing dog name, I want to store maybe the breed, also maybe the sound dog makes, and maybe the color of the dog fur. So this is stuff I want to store. Again, I can store whatever information I want, but I pass that in as values, and then I attach it to the instance. So I'll do self.breed. I see some hands raised, so please ask questions. Any questions out there?
Yeah, this is Andrew. I feel like you're probably gonna get to it, but if you put in like one of the initial variables for initialization as like a list, would it have to be like self.list and then you can access with bracket notation after that?
Sorry, could you repeat your question? So you said if I pass in a list, for example?
Yep. Like instead of color, like maybe just a list of, it doesn't really make sense in this case, but 0-1.
0-1.
I mean, a list
Like,
of 0 and 1.
Think of it like a list of
Yeah.
the dog's favorite toys. So that
Yeah.
parameter
We'll
Yeah.
do tricks.
related to
Yeah, so let's do
Yeah.
tricks. I'm going to say winter. Breed was, I think, golden doodle. We had colors, probably golden. Tricks, let's say we're going to pass in a list here. So we're going to do roll over and then also fetch, if that's counts as a trick. And then we could also have one more trick, shake. And then sound, we could say wolf. So notice I defaulted my sound. So if I don't want to pass in sound, I don't have to. So it's actually not passing sound here. We want to store self.tricks equals tricks. All right, so we got this list. Andrew, can you continue on with your question?
Yeah, you just access it. You can now access it using like just regular bracket notation.
Yeah, so tricks, let's say the second trick, like if I know for sure there's at least 2 tricks, I could access tricks bracket notation 1 because the data has been bounded to the instance. So winter.tricks.1 at 1 should print out, what is it, fetch. So if I do Python classes, notice I get fetch here, but I got some errors because now I've said every dog must have a name, breed, color, tricks, and sound associated with it. So let's complete that. While I'm typing this data, could you guys ask your question?
Hey, this is Porphy.
Go for it.
My question was just what happens if you try to call an instance without giving it like a name, like how it's Winter or Ice or Murray? If you just put in dog and then put in a bunch of parameters, like will it break it or?
No, it won't break it. It's a good question. We'll definitely cover that. Thank you for asking that question. Let me just finish this example. Kat, what color is your dog, if you don't mind me asking?
Yeah, black and white.
Black and white, all right, black and white. And then Justice, what's your dog's color?
Also, I mean, black and gray.
Gotcha. So we had Great Dane, black and gray. All right, just want to be accurate here. Obviously, I can put anything I want, but black and gray. Let's say a Great Dane says bow wow. I don't know if dogs should say that. Yeah. So now I believe the question that Porphy asked was, what if you don't assign it to a variable? That's fine. That's the same thing as if I just create a list right here, 1, 2, 3. This list getting created, but if I'm not storing it, it's just gonna disappear after this line of code. So I can create my dog right here, but if I don't store it anywhere, it's just gonna disappear. Basically, we create a dog and then delete a dog from memory. It's not gonna break anything, so we could do this. If I ran this, it should work now. So notice we got winter, because you're printing out winter.name. We got fetch, because yes, we have a list data. So again, you can have any data types you want that you're storing. So we stored a list. We can access that list just like normal. And we get fetch, and then we also have ice.name. So we created a dog here, but we don't do anything with it. So, it kind of just goes away. More questions, keep them coming.
I was wondering, as far as like he was talking about putting the list in there, would you be able to access all of the dogs that know the trick fetch?
That would require a more standard approach where you need to store your dog instances and probably use like a for loop. So I could throw like maybe winter, ice, and Murray into a list and then do a for loop through each dog instance and say, hey, so let's actually do that. So if I wanted, I could say all dogs equals winter, ice, and Murray. And then I could do a standard for loop for dog in all dogs. If dog dot tricks. Actually, I should do a for loop here. So I'll do a for trick in dog dot tricks. If trick equals, let's say fetch, we're searching for fetch. Maybe we could print out, let's do f string. Just doing more examples here, but good to see them. So we'll do dog dot name knows how to fetch. Does that make sense?
Could you also possibly use enumerate to get the index?
Yeah, we could use enumerate, but in this case, like our index doesn't really if we wanted the index, we could use enumerate. But again, in this case, index doesn't really matter much to us for like dog information. Like index dog 0 probably doesn't matter to the user. Yeah, if we want to use index here for some reason, we could use index. But yeah, so again, here we created an all dogs list right here. And then for this example, we want to see which dog knows how to fetch. So we go through each trick in the dog's tricks list, right? Like right now, only winter knows how to fetch. So we ran this. Let's actually add fetch to Murray. What else? Play dead. Let's say cat's dog knows how to type on the computer. Fancy dog there. Right, but cat's dog does not know how to fetch. So based on this print statement, we should get 2 outputs. Let me get rid of some of these so we don't confuse ourselves. All right, so now the question we're answering with this for loop is, which dogs know how to fetch? So we iterate through all dogs. We go through all their tricks. And then if we find a matching trick, we print it out. So I ran this. Notice 0 is the index we captured. We got winter knows how to fetch and ice knows how to fetch, but obviously cat's dog does not know how to fetch because her dog is busy typing on the computer probably. Okay, so we added more
Her dog
data.
is ice, though.
What was that?
The pronoun ice knows how to fetch. Not Murray knows how to fetch.
Oh, sorry. Oh, this would be Mercutio. Sorry, Mercutio. Forgot to change the name. Thank you.
Oh, there.
Yeah, that was my mistake. So it was second dog, not ice. Yeah, so I added more data, but we'd also add methods. So actually, let's add a fetch method. Let's say fetch is like a trick that every dog knows. So here we do self and item. And let's say, these dogs will fetch something. So I'm going to print out to simulate fetch. I'm going to say self.name fetch the item, and definitely make sure we discuss what's going on here. We're using string interpolation, which is the F string, and this should be close to quotes. All right, so now let's say every dog can fetch. Again, that's not like a magic trick. That's just every dog can do it. So we added a fetch method. So the way we use again, data and methods, generally speaking, your data should be nouns. So like a name is a noun, color is a noun. Your methods usually will be verbs or actions that your class can take. In this case, a dog, it's pretty easy to imagine actions because dogs can run, fetch, sleep. But again, that's true for any type of class you're creating. The data should be nouns and the methods should be verbs, as in like get data, set data, compute values. Those will be methods that you create for whatever class that you might conceptualize here. So let's comment this out. I added a method called fetch. So again, just like any function, I could call this function on my instance. So if I do print winter.fetch, again, this is a function. So I got to call it with parentheses. And in this case, takes in one item. Again, self, that magic keyword still exists there, but that is not something I need to pass in. That is something Python would automatically pass in for this instance. So it's a fetch ball. Now we could run our code. Python, notice winter, fetch the ball. I guess I don't need to print in this case. So my fetch method is printing and saying what winter just did. So that's why I should get winter fetched the ball. Questions? I saw hands raised. Just keep them coming. Questions? I see 4 hands. I can't see you guys, sorry. So please just ask.
Those the greater than signs in your string interpolation, is that specific to when you're calling methods?
Nope, that's just for design. Just again, I just did that just to have something in there. But no, those are just in my string. Nothing required. Just to have something here. Other questions?
Yes, as far as the question where which dogs can fetch, is it better to do that like you were doing with the for loop, or is it, if you're going to be accessing it maybe regularly, is it better to create a method that creates those lists of dogs within the class?
Good question here. So you can, it all comes down to your use cases. So I think Grant's question was, well, we created an all dogs list right here. Should our class be able to do that? There's a yes and no answer to it. I'm going to say no for the instance, meaning winter being an instance of a dog does not have any knowledge of any other dogs that exist. So it would not make sense to have a method say, get all dogs for the instance. Now I'm particularly highlighting the name of instance. Like this wouldn't make sense because winter has no knowledge of other dogs. So it's going to be impossible for me to know, all right, ice exists and Mercutio exists. However, there's an idea of class methods, and we're not going to talk about them today, but there's an idea of, well, I have a dog class. If I want to keep track of all dogs that get created, I could have some data inside my dog class that is not tied to a particular instance. It's just universal to the world of dogs. Again, I don't want to talk about too much about this because we're going to focus on Wednesday, but let's pin that thought or table that thought and we will get to it. But yes, your dog class could have some mechanisms to keep track of all dogs if that was something that we wanted. But excellent question. All right, more questions. I see more hands raised. I can't see who you are, so feel free to ask.
Here's a quick question. This is probably really basic. I just want to make sure is that you have to like declare the winner instance before you actually call the method of it?
Yes, absolutely. Because yes, this is called an instance method, meaning this is something each particular dog will do. I can't just say, dog.fetch, because this is a concept, right? There's no actual dog that could perform a fetch operation, right? It's an idea that dogs can fetch, but I need an actual dog to actually do something in the real world, which in this case is fetching. So yes, you always need an instance to access the members or the methods in a class. And these are instance methods. Again, there's a concept of class methods, but we're not going to cover that today. So just for now, yes, you need an instance to access the behaviors of the dog. It could be fetch, it could be sleep, whatever methods you want to simulate in your code, you can do that. I see more hands raised. Keep the questions coming, please. No more questions?
Another question, sorry.
Sure.
So if you don't know some of the attributes within a instance you're trying to declare, is there a way like a character or any symbol you can put in there temporarily so that you don't break the code?
Yeah, so Yelin's question is excellent and something I definitely should cover. So here, when you create an init method, everything in this list, if it's not optional, is required. So in this case, dog name, breed, color, and tricks, I've said it is required for my design here, right? Now, Yelin's question was, well, what if you don't know tricks right now, or maybe not all dogs know tricks? Like I can make that, let's say I take away tricks here. So now tricks is not a mandatory parameter or data for every single dog that I create. Again, the init method applies to every dog you create, but let's say you have some special dogs out there. So let's say in this case, Ice is able to do some tricks. I'm going to get rid of the tricks array because not every dog is going to have tricks, but you are able to create special instance variables for one instance. So I could do ice.tricks equals, computer and reading a book, whatever. So now I've created an instance member only for Ice. So what I mean by that is if I go down here, let me get rid of this stuff. I could do print ice.tricks, and that will print out the value I created. So basically I created a new variable only for Ice. So this is different than before, because now if I did print.murray.tricks, this is going to cause an error because this variable does not exist for Murray. If I did want to guarantee this existed, I would create that in my init method. I would say self.tricks maybe just equals an empty list. So now I could access tricks for any dog because I guarantee that it got created when the dog got initialized. But if I don't have this, then not every dog is going to have that tricks variable or that tricks attribute. In this case, Ice will have it, but Winter will not. Murray will not, because I've not created it. So yes, you are free to create additional data members after you create your dog instance or whatever instance you're creating. I can create as many new variables on that instance that I want. That is something that is capable with Python. Okay, any other questions? I see 2 more hands raised. Please ask. I can't see who you are.
Hey, it's Andrew. So I had a question. It kind of goes a little bit further on the question I was asked earlier about you have to create the instance before you can call it. Couldn't you call it and then create the instance within like the parentheses for the call, and then it'll create it before it calls it?
Sorry, you totally lost me. Could you kind of guide me here?
So winner.fetch ball right there.
Yep.
If winner wasn't created before, you could, within the parentheses and winner.fetch, you could call like the line dog winner Godin Doodle Godin, and wouldn't it create the instance first and then it would call the fetch thing second?
Are you saying do something like this?
Yep.
You can, but again, I want to always go back to, you're trying to map real world kind of behavior here. So here you're saying some dog that doesn't exist, like create a dog just to go do some fetch action. Like that could work programmatically, but conceptually, you need a dog to exist before you can fetch for anything. You're not going to say, hey, some dog go fetch and some dog just magically gets created when I throw a stick, right? So yes, this could work in some design, but I'm going to say that's probably not best OOP design. Again, the idea here is you have a factory or a blueprint where you have an idea of a dog, you create those dog instances, and then you act upon those dogs, as in you call methods or do whatever you need to do. Any other questions out there?
Yeah, actually, so if you were to create a class, so say you're a dog, right? And now you're starting to add on new attributes, right? Or what is it?
Yep, attributes, you got it.
Yep. So say you're starting to add new attributes, and later on you wanted to maybe see what attributes that particular dog has. So that instance, is there a way that you can list those out?
Great question. I know there's a help method. Let me try this. I want to say yes, there is in Python, but there's a help method. So let's do help Ice. I'm not sure if this will work. I know it works for class definitions, but
I mean, you just want to print out all the attributes and methods for each instance. Is that what you're saying?
Yes.
I think vars, keyword vars, will show everything.
Is it bars like that?
Yeah.
Okay, cool. So do I need to print that out maybe? Bars. Yeah, again, Python has a lot of built-in methods, so I'm going to say it's probably possible. There we go. So we see all the variables. I assume that's what bar stands for. So we have name equals ice, breed, color, and we have that tricks. The tricks attribute that we created for ice that is listed in bars. So yeah, Jake, thank you for that tip. You can call vars and you get basically a dictionary of every attribute and value for that instance. So that's kind of a neat trick. Yes, cool, cool, cool. All right, let's continue on here. So we created, again, an init method to kind of initialize our dog instance. We provided some data attributes. That's what these are. Again, we're attaching that directly to the instance. So this is the same idea with our object where we kind of bundle it together. This is the same thing that's going on with our class. We're bundling all these data numbers to our instance. So in this case, and Winter has a name attached to it, to her, for him, and it has a breed, has a color, has a sound. All right, so let's continue on with our slides. So we saw our example. That was the slide. Last thing I want to talk about are Dunder methods. So obviously, Office fans, hopefully you guys get it. But Dunder stands for double underscore. This is a Python term, again, not universal to all languages, but Python has special methods that are also known as Dunder methods that you can use within the class. So one example of a Dunder method we already saw here. This init method is a double underscore method. This is a special method reserved that Python can kind of access freely. But this isn't the only game in town. So let's actually do something. Let me get rid of some extra code here. Let's just get rid of these dogs for now. All right, so we have Winter, right? Winter is able to fetch. What if I just do a print Winter, right? I'm just printing out a value, simply like, we do value equals 1. I want to print out value. Again, you guys hopefully understand the idea. We just want to print something out to the console. So I'm going to do that with Winter, dog instance Winter. What actually goes out to the screen? So I clear this, run it. So notice Winter fetched the ball. That is the fetch method. But when I print it, notice I get this weird output. I get main dog objects at some memory address. Cool. I mean, that's not really useful to me as like a user of this application. I don't care where in memory it's stored. I don't care what type of object it is. I just want to see something more useful. So another popular Dunder method, again, these are methods that exist that Python will automatically know to call, but you need to name it the way it expects. So there's a Dunder method called str, short for string. This takes in self. Again, every instance method, as you notice, takes in self. That is, again, a parameter. It's always going to be the first parameter. It should be named self, but you can name it whatever you want. In this case, I'm not going to pass anything in, but let's print something out to the console. Let's return something from this method. Let's say f-string self.name. My name is self.name. And I say self.sound. All right, so now we've created like a description in the str method. This is automatically going to be used when we try to print a value out. So again, Python does some work behind the scenes. It says, all right, you want a string representation of your class. I will call your string method for you since you have defined it. So now if I run this, Python classes.py, notice I get a nice user-friendly output. My name is Winter and I say wolf. So again, you could put whatever you want in your string method as descriptive or non-descriptive as you want. It's your choice as a developer. Breed. Okay, so again, that's another Dunder method that exists. There's a whole list of them. You could do a Google. I believe we linked it on our curriculum page. So let's find that quickly. So we talked about class introduction, init method, instance attributes. This is your data, and instance methods are your actions that you perform. So we did I guess a fetch. Okay, let's go to other Dunder methods. So we added str. So we're kind of getting through this. Where's that link? I'm looking for a link here. Oh, here it is. So click here. Let's find out a whole list of Dunder methods. So So there's add, there's subtract, multiply, floor division. Again, every pretty much operation you can perform, there's probably equivalent Dunder method. So if you do a plus equals, like that is not natively defined for each class you create, right? So if you want to have some functionality for plus equals, you can create a Dunder method or you employ a Dunder method and add some functionality. So again, there's dozens of Dunder methods. I'm not going to go over all of them. There are a few popular ones you might encounter. So init, we talked about. This is a method that automatically gets called by Python when you initialize a class instance. str, we just saw, that's a string representation for your data. Again, you get full control of how you want to represent your dog class or whatever class you're creating. Repr is very similar to the string method. So similar, in fact, I don't know the exact differences, but repr you might see. Again, there's other methods. So equal, if you want to consider two dogs to be equal, well, Python doesn't know how to determine if two dogs are equal or not, right? That concept is something that is user defined. Python is not a dog-oriented language. Same thing with add, like adding two dogs together. Python's gonna be like, what are you trying to do? Python can't just naturally know what the plus sign is gonna do. But if you want to use the plus sign as an operator for your class, you can do that by implementing the add Dunder method. So just for this last example, before we wrap up here, I'm gonna implement the add method. But before I do that, let's, I hope Kat and Porphy don't mind, but I'm gonna do something like print winter plus ice. What does this mean, right? I'm using the plus symbol. Let's try running this and see what happens. So let's get rid of this print. Let's say we're not gonna fetch anymore. So I created two instances, winter and ice. I'm going to print winter plus ice. Notice you get an error. It's saying unsupported operand plus sign, dog and dog. Basically, Python's saying, I don't know how to add two dogs together. Python's like, what are you trying to do? So that's why we get an error. But let's say for this crazy example, we want to implement it. Let's implement the add. Again, this is an instance method, so self is going to be the first parameter. Let's say other dog will be the second parameter, because that's what the add sign does. It basically takes one instance and then passes it another data type. So let's say it's going to be other dog. And let's actually return a new dog. New dog will have no name. Let's say the breed's going to be self.breed plus self.otherBreed. Sorry, other dog.breed. Color will be, probably need a space there. All right, so I'm basically, if you guys kind of get the idea here, we're creating a new dog because two dogs are getting together. They do what they do. They create a new dog. So we'll do self.color plus, again, this is not how genetics really work, but I'm just gonna do this for our example. Let's say the new dog's gonna be a mix of both colors. So other dog will be other dog color. And what else do I have here? Sound. Let's just put no sound. All right, so now I'll say when we use the plus sign, that's actually going to create a new dog, right? It's going to be a puppy that's going to have no name initially because we don't know what the default name is. But the breed is going to be a combination of the breed and a combination of the color. So let's actually add that here, self.color. All right, so I'm updating my str method. Okay, so let's actually see what happens now. So now when I print winter plus ice, that should actually be creating a new dog. And that's what's going to be printed here. Or I could, save this. Let's say new puppy equals winter plus ice. And then I could print out new puppy. Just kind of do it in two different steps. Puppy. Okay, so again, this is a special Dunder method, must be named __ add. Python will know, okay, you're using the plus operator. I know how to handle that now because you told me how to handle it. So if I do this, let's run it. And here we go. We got my name is blank because there's no name for a new puppy, but I'm a golden, black and white, golden doodle box of collie dog, and I say wolf. You guys kind of get that? Because we said, hey, when we create a new dog, we just combine the breeds, we combine the colors, and that's how a new dog gets kind of defaulted with some values. All right, so winter and ice made a new puppy, and that puppy has some attributes to it. All right, so again, there's multiple Dunder methods. You guys can do a Google exploratory session on if you want to know all the ones that exist. But again, the main ones to know are init for sure. String is heavily used. Adding equals, not really used too often, but they're kind of cool to see. Again, if you want to compare two dogs and determine if they're equal, you get to determine how two dogs are equal. You could say, hey, if they have the same name, they're considered equivalent dogs, or maybe if they're the same breed, whatever your equal method may want to determine, you have control over that. Okay, so we are getting close to lunchtime, so want to wrap up here. Key takeaways. So again, we had some slides, some boring slides, but at the base of it, know what object-oriented programming is. Maybe if we didn't cover that fully, let's say that right now. Object-oriented programming is the idea of where you're creating objects to represent the real world, right? So you create blueprints, which are your class definitions, and then you create instances, which are the actual objects. That's why we get the term object-oriented programming. You're creating objects inside of your application that reflect some idea in the real world. Know what classes are used for. So again, classes are user-defined types. You get to decide what data is included in there. You would have, integers and strings and lists, whatever data you need to bundle together. That's what your classes are doing. They're user-defined, as in you, the developer, get to define what that data represents. Also, know how to create a class in Python. Again, know the syntax for it. I want to make sure we highlight that. So the syntax, again, keyword class, then the name. Usually we use uppercase, camel case, colon, and then we define methods. So we have an init method, we have str method. We also have our own custom methods, fetch and sleep. And then we also want to create data. So again, classes are made up of attributes, which are the data, and the methods, which interact upon the data. So in this case, our fetch is kind of interacting upon the name and the, I guess the item that's passed in, so that's not an attribute. But we have the name that is used within this method. We also have a sleep method that interacts upon the name. So again, this is kind of getting ahead of ourselves. We'll see this more on Wednesday, but to see more interaction, let's say update sound. Right, so we have a method that's going to interact with our data internally. So you do self.sound is going to equal new sound. Right, so we have a method specifically to interact with this attribute, which is self.sound. Now, in the back of your head, you might be saying, well, Encore, can't I just do something like ice.sound equals hello, right? Because we have access to this number because we created that in our init method, right? Self.sound got created. So self.sound, we could assign to it. We assign it hello. Won't this work? Like, won't ice now say hello anytime ice speaks? The answer is yes, but this is not proper OOP design. And this is what is usually some of the most complicated things from OOP week. A lot of students kind of get flustered because like, well, it works. Why isn't this the best designs? A lot of OOP is conceptual, a lot of design oriented. There's plenty of different ways to achieve what you're trying to do in your application. OOP is a philosophy, and that's what we're trying to teach with this week. So it's going to take some time to kind of understand what the philosophy is preaching and why it's beneficial to do so. So I'm going to table this question of, well, why can't we just assign directly? It's going to work, right? The answer is yes, it's going to work, but no, it's not good design. Instead, we should create a method, such as I've done here, and call ice.updateSound to hello. And again, the difference right now seems subtle, but there's a reason why we want to do this. And again, the why is everything in your class should be one entire package, right? So if I need to interact with this data, I should have a method to do it rather than me as an outside observer messing with that data directly. So again, if you're confused right now, let's take a deep breath. We'll cover this more on Wednesday. Just want to talk about some additional things to consider when we're designing our classes. Okay, that was a lot. Again, this was just our introduction to classes. High level, again, key takeaways. Know OOP, know how to create a class, and importantly, know the difference between a class and an instance. A class is a blueprint, it's a concept, it's a class definition that you create in your applications. When you actually use those class definitions and create an instance, like you create winter, which is a dog instance, ice is a dog instance, basically an instance of the dog class, if you want to say it a different way. Mercutio is an instance of a dog class we created. So an instance is a real world physical object that you can kind of imagine, versus a class is just a concept or an idea that doesn't really exist until you implement an instance of it. Jidan, you have a question?
Oh yeah. So I'm just wondering, I know in Java, like when in the memory, you know, you have stack and heap, and the object itself is usually saved in heap, and then the reference or the method are saved in stack. So I'm just wondering if it works similarly with Python.
That's an excellent question. I'm not going to pretend I know. So I know with other languages, when you use like the new keyword and dynamically create memory, that goes on the heap, but versus static data goes on the stack. Hopefully I'm not screwing that up. I don't know the details of Python well enough to answer, so I'm going to say, hey, I honestly don't know. We could maybe Google that, but definitely an intricate question to ask.
Okay.
I was curious on Google, but any other questions out there? Yeah, it looks like there's a great article for it. So Geeks for Geeks, usually a good programmer site. Anyway, any other questions out there while I kind of scan this?
Yes. I was wondering about the one of the assignments for tonight, the find shared contacts portion of the method that you need to do. How would you do that? Or do you have a general direction that we should go to do that without the method acting on the class itself?
Gotcha. So great lead in. So I did want to go over the challenges for tonight. So Grant, thank you for mentioning those. Let's actually go over the three of them just to get you situated. So we have three challenges. Grant mentioned the contact list. Here, we want to create just some representation of our friends or work buddies. So we create contact list entries, or it looks like we create actual contact lists. So we have different lists for, you know, friends, work buddies, maybe family, different lists that we create. And we should be able to add methods. So Grant, sorry, could you reiterate your question? Like we create a contact list. If we want to add a new member, we create an add contact method where we pass in the data for the member. So, you know, we have friends, Alice and Bob. Let's say we want to add a new friend. Let's say Grant wants to be my new friend. I add him to my friends list. I would actually pass that data to add contacts, and add contacts would take care of the work to actually update the internal data for that list. Again, I know that's a mouthful to say, but the idea here is you create methods to update your data internally instead of updating the data directly. This is a design principle. You can get away with doing either or, but there's a reason why we want to have methods that do the work for us rather than us doing the work outside. Like as in, if I create the friends list here, instead of, again, updating the data through friends.contact list or whatever list data you have inside your class instance, I'd rather have a method that updates the data, because that's the idea of classes. You have data and methods that update or interact upon that data. I don't know if that answered your question.
Somewhat. It's more the find shared contacts method that you'd like us to make.
Okay, gotcha.
So that's going to act on the contact lists that we've already created.
Yes.
And I found like when I try to act on those, I get back like the, you know, the weird object number that it gets, you know, I get like a list of that.
Yep.
And is that something that we can use the string thing you were talking about to?
Yeah, so if you want to just see nice output, that's why the str method is used for. I think I understand your question now. You're saying for find shared contact, we pass in a contact list instance, and we want to compare, hey, my friends list, let's pass in my work contact and see if there's any overlap. That's what this method is meant to do. The question is, how do you access, you know, the members from the work list? In this case, when you're reading values, it's fine to just do like, here, let me go to my code window because I'm kind of jumbling here. Like if I want to read Winter's name, before I was just doing prints.winter.name. Now I am kind of accessing this data member without a method. This is fine, more or less fine, because I'm just reading a value, I'm not updating a value. But I guess there can be argument made that I should probably implement a method that does print winter.getName. Get name, and then that should return the name for me. Again, we're kind of splitting hairs here. This is probably the more proper approach where you have a get method that might simply just return you winter.name. But there's a reason why this might be preferred over just getting the name. For your contact list, you can just access it directly, or you create methods if you want. You could just say, here, for example, you could, again, we're telling you what methods should exists, add contact, remove contact, find shared contact. But you could add more methods. Like in this case, you could say, does contact exist? And maybe pass it a name, right? This could be a viable instance method where I'm like, all right, does Alice exist as a contact in my list? Sorry, I'm using dogs right now, but imagine this is a contact list instance. We have a method called does contact exist, and pass it a name. And maybe if it does exist, we get a true back or a false back. And that can be used to implement or help you implement find shared contacts. While we're kind of on this topic, I want to make sure I mention this just because, again, classes are new to a lot of us. You can call one instance method from another. So for example, if I wanted to call self.sleep here, I could. So in this case, my design is saying anytime a dog fetches something, they fetch it and then they decide to take a nap because they're tired out. So again, here, I'm calling my other instance method by using the self keyword. The self, again, remember, refers to the actual instance. In this case, I'm saying, hey, Winter, go fetch something, and then Winter, go sleep if I call winter.fetch. Right, so again, you are totally allowed to call other instance methods from one instance methods. That, again, that can be viable. So in this example, if you guys don't pardon my mess, if we had a context list class, contact list, right, we'll probably have some init method. I'll leave that to you guys. But here, I'm thinking we could have define does contact exist, and then maybe a self and a name of the contact. And then we do some work here. And then I might have another method called define find shared contacts. Right. And then this method will likely use my other instance methods. So I do self.name, other contacts list, and maybe I'll probably have a for loop and say contacts in other, or contact in my list, say self dot. Again, I'm kind of spitballing here, so I hope you guys can stay with it. So I have a list of contacts in my current instance. I could probably for loop over other contacts in other contact list. Maybe say if other contacts list does contact exist, and then pass it to contact. So I'm going through my current contact list, getting the contact, and then I guess in this case, I wouldn't need that loop. I'll just do other contact list. Does the contact exist in that? Sorry, I don't know if that's confusing you guys, but this idea of create a separate method that does some work for me, and then I could call that method from here too. Grant, did I confuse you, or does that kind of make sense?
No, the last part, that was mainly.
Sorry, you got muted halfway through.
Sorry. That was mainly my question about doing the methods like on other methods. And as far as the shared content, just some clarity on the question that's asking. So we're putting in a contacts list, and then you're just comparing it with a different list, the same list. It's because it says should accept another contact list argument. Yep, and then return a new list of dictionaries to indicate all the contacts that appear in both lists.
Yep.
Is that just in general, or is it just for these two lists that are specified?
I want to say the latter, if I understand correctly. So basically, I have a contact list. Let's actually formulate this. Again, I know we're in lunchtime, but let me quickly go over this. Let's say we have a friends list. I can spell friends list is a new contact list instance. And then I actually have a work lists. All right, so we have two different contact lists, right? Like my friends list might be Grant, Alice, and Bob. My work list might be Tom, Raphael, and Rod, right? So work, this is contact list. What the challenge is asking for is you should have a method where I could call friend lists dot find shared contacts. I could pass in another list. It could be my work contacts, could be my family list, whatever list you want to compare with. So in this case, work list. So now I'm passing in another list, but I still have my current instance. So when I call this method, Self is going to refer to friends list. Other contact list is going to refer to work list. And my goal here is to find the overlap. So it looks like we need to return a new contact list with the shared contacts. Right? This is the data you need to create by doing some logic here. Again, I'm not fully coding this out, but whatever logic is doing here, if you find an overlap, yep, Alice is both my friend and my work contact. Well, then I should create a new contact list that has Alice as that overlap. That's what the problem's asking for.
So will these be two different instances, or do these two different lists be two different instances versus like saying have like a global contact list that's filtered to, you know? So like
Correct.
basically you add, okay.
Yeah, I don't think we're creating a global contact list. We're just creating separate contact lists and creating new ones, you know, to see overlaps is what I'm doing.
Okay, that's what I was, okay, thank you, that was it. Yeah.
Well, that's how I read this. Again, I want to make sure, but that's what it sounded like to me. All right, next challenge, we have a simple introduction to OOP challenge. This is going to be kind of a 3-day challenge, but app users, we're just going to ask you to create a user class and source information like a name, email address, driver's license. Again, the practice here is just to make sure you understand the syntax, understand the init method. So you should create a few users to kind of, you know, create instances from your user class. So again, pretty basic challenge, but you want to make sure that you kind of have the foundations for creating classes and, you know, the syntax and instances and whatever, you know, basic things we went over today. The last one is guessing game. So this one's more of an algorithmic challenge, but it's going to employ some OOP. So we're going to ask you to create a guessing game, very simple guessing game where it's like, hey, guess a number between 0 and 100. And then like, let's say I'm playing with Grant. Grant, you're on my screen. So I think of a number, Grant says, is it 37? I'm like, nope, it's going to be higher. So basically your application should return, you know, lower or higher. That want to make sure I get this right. Sorry, you return low if the guess is too low. So if Grant says 37, I'll say, nope, too low. So then he'll know to guess higher than 37. And then he might guess like 77. I might say too high. And then, you know, he keeps guessing until he gets the right answer. So if the guess, you know, if the answer was like 57, my application should output correct when Grant guesses 57. And then there should be a solve method that returns if the puzzle has been solved yet or not. All right, so we have some starter code for you that you can employ. But again, your goal is to implement a guessing game class that will take in the answer. And then I should be able to call a guess method to keep guessing and see if it's too low, too high, or if it's correct. All right, so this will be a good OOP challenge for you guys. All right, so those are your 3 challenges for tonight.